Okay. Hi, my name is John Liang, and I have with me Mike Ranieri. I'm a principal engineer at Intel. I'm also the IC representative for hardware management. So I oversee most of the hardware management projects and lead most of the project leads. Mike is a senior engineer at Dell. He is a co-chair of the Redfish Forum within the DM TAF. And he also runs the Tools Task Force, which implemented most of the conformance tests that you see today. Where did I point this puppy? Better yet. Okay. So the outline is just an outline of our the design specification template. So the OCP created 2 documents this year. One was a design specification template update, which references manageability compliance. It has a chapter on it. It also references a supply checklist. So the design specification template is for those submitting designs and latest design files to OCP. The supplier checklist is for vendors who take a design, implement a product, and then attempt to contribute that product into OCP. They've also updated the checklist so that there are specific things that product vendors need to make sure they conform to before they contribute a product. That's part of the testing that goes on. Then I'll overview the 2 profiles that currently exist. There's also a rack management profile, but we won't get into that. That'll be discussed later on. So there's a baseline, which Hemel had mentioned, which goes across all OCP platforms, and this provides a common baseline of manageability across all OCP platforms. And then each vertical platform gets to extend beyond that. So you say all platforms should you should be able to reboot them. That's in the baseline. If it has a compute unit, then it's in the server platform. If it has a whole set of disk drives, it may be a storage platform. Why? Let's keep moving. Okay, and then last is I'll hand it over to Mike to describe the execution and testing of all these conformance tests. He will not go through it in detail. Basically, he will show you how simple it will be to actually download it, execute it, and look at the results. Okay, so this is an excerpt from the 2021 design template. So it basically says that all products, whether inspired or accepted, will have to comply with the hardware management baseline profile, which means you have to run the test against the profile and make sure you collect up the results and attach them to your submittal. And then as evidenced by whatever's in the supplier requirements. So the baseline is a requirement. So if you have a particular type of platform, let's say a server, then you have to see if a server profile has been written. A number of the platform groups have come back and said baseline is fine for us for now. We'll take our time actually extending our profile for our particular platform. So to date, we have the baseline profile and the server profile, which is extended from the baseline. So now if I go across to the server checklist, which was referred, this shows exactly what the conformance tests that need to be run. So there is a service validator, a protocol validator, a interop validator, and then a use case, which is optional. So as I talked about this actually in the Experience Center, one thing I can mention, the Experience Center currently has all this running. Mike is manning his booth, which is to go through these tests and run them and show you what the examples are. In the same booth, we have Device Manager, which had been mentioned earlier and will be talked about, and we have MegaRack. So for the question that we had about AMI MegaRack, you have 3 people from AMI you can direct that question to. Okay? So the service validator validates that Redfish requires not only a resource tree, but specific services that exist, event service for pub sub, account service for users. That's what the service validator tests. The Redfish protocol validator tests the HTTP-ness of whether that works correctly, whether you get the right return codes when things exist and don't exist. And then the Interop Validator is what consumes the profiles. So the profiles are all written in JSON. They're machine readable. They're read by this thing. So the Interop Validator basically reads the profile, auto-generates all the tests that prescribe what resources and what resource properties need to exist, runs it against a conformant implementation, and outputs the output file. So in one fell swoop, you can go off and take a look at that. So this is the same process that when new profiles appear from each of the platform projects, that they will run through the same system. And then you can run all the top three validators and everything could pass, and you could still not actually, you've never actually done anything to the system. So on the last line is a bunch of use case checkers, which actually have, there's 8 use cases that we go through the entire front to back of performing a particular manageability action. And we want to make sure that we can do that on a particular platform. So this is a little bit of an eye chart, but it's the only way I could fit all the use cases that are available. So on the left-hand side are the use cases that are available via the baseline. These are all things you can do. You can power cycle the system, you can get its logs, you can manage the entire management controller as far as setting up its NIC. And then on the right-hand side is the server profile. So in addition to everything on the baseline, you can now do everything on a compute node. So you can determine what your systems are, get information from it. You can get a system inventory. You can determine the location of it. You can get the version of the system firmware. You can set boot information and boot paths, and then reset the system. So these are all things that we felt on a compute node you want to be able to do. We've offered this up to the other platforms that they could use this as the basis of their extension, or they can write their own extensions. So the DMTF, who owns Redfish, also is a pure standards body. They only do standards. And they're very concerned about the interoperability of standards, because that's why you want standards. So they've established a Redfish Interoperability Lab, and this is where Redfish members can send their platforms. And we run the entire set of conformance tests that you saw listed against these set of tests, against these systems about every 2 months. And we want to make sure that all of them pass, and if they fail, we want to understand why. Because they may fail for multiple reasons, and one of the worst reasons is that they both read the same spec and they both interpret the spec differently, which means the fault is not in the implementation, the fault is in the Redfish spec itself, that it allows dual interpretation to occur. And so that causes us to file an issue against the spec, and the Redfish forum can go cuddle and determine what is the correct interpretation of the specification. And then secondly, if the specification is okay, we want to make sure that everyone has implemented it the same way. It's very easy to do things arbitrarily different when you're developing, and we're trying to prevent that from occurring by running these on a consistent basis. Okay, so so any member of the Redfish forum can arrange to have the platform or a platform sent to the lab to be part of this testing, and they will have access to the test reports that we come out with. Okay. And with that, I'm going to hand this over to Mike.
All right. Thanks, John. I'll be going through how to run these tests. So as John mentioned, we have 4 major classes of tests. We have our service validator, protocol validator, interop validator, and use case checkers. All the tools, they run in Python 3, so if you have that installed, you're 90% there. There are some additional installations on top of that, but we'll go through those on the subsequent slides. To run the test, it's really just a matter of setting up the right config file inputs. In some cases, you can just input things directly on the command line, and you point it at your system of interest and let the test run and see what the results look like. So looking at the Redfish protocol validator, so this is really tests how a service conforms to the Redfish spec from a protocol perspective. So ensuring things like HTTP headers are set up correctly, response codes are sent back consistently. Once you have the tool cloned from our Git repository, you can just use pip to install all the required modules. And then to execute it, you just provide it with the username, password, and the service entry point for where you want to test. And then afterwards, there's a logs directory where it outputs the HTML and text files. You can inspect the files from there. At least breaking down what that type of report looks like, it's just an HTML page that you can open up in a browser, and the results kind of step through each of the types of the tests that are invoked by the tool. So it's broken down based on the shall statements within the spec. So this first one, proto etag on get account, it's to validate that all manager account resources return the etag header. And then within each of those buckets of tests, it will show which resources were used as the test point for validating its conformance with the spec. Gives a pass-fail metric, and it gives the HTTP operations and response codes that the tool observed. And if the test failed, the right column with the message will give more explanation as to why the test failed. All right. So the Redfish Service Validator is the next level of tooling. So the purpose of this tool is to verify that all the resources presented by the Redfish service conform to the schema definitions published by the DMTF or even OEM extensions published by their respective vendors. Again, like with the protocol validator, you can install the required modules after cloning the Git repository from using pip. You fill in your config file inputs, which predominantly you would be giving the username, password, and the service entry point. Those could be passed on the command line as well. It's up to you for how you want to run the tool. And then you just invoke the tool and inspect the results in the same way you did with the protocol validator. So kind of the similar way that the protocol validator has its output as an HTML page, and it breaks down each of the types of testing that it does. The service validator has sections per URI that was tested. So every URI that's on the service is put into the report, and then you can go inspect how that particular instance of a resource conforms to the schema definitions. It gives a general pass-fail metric at the resource level, and if you want to expand the results, maybe you need to do a deeper inspection because you have multiple failures on a resource. It presents you each of the properties, the value that was observed by the tool, and tells you the reason that it may have failed. It also gives you the full raw payload of the resource if you need to do further inspection for trying to line up the results with what was presented by the service. The Interop Validator takes a step above the Redfish standard itself. So as John pointed out, there are profiles that OCP is constructing to describe the additional requirements that are going to be needed for conformance with OCP work streams. And so those profiles are consumed by the Interop Validator and tested against the service in question. So again, like with the other tools, clone the repo, install the dependent modules, optionally set up your config file if you want to have your username, password, and service as part of just a file input or provide it on the command line, run the tool, and check out the results. So we have an HTML page for this like with the other ones. The output is much more similar to the service validator since it's going to inspect every resource on the service And for each resource, it's going to check the profile in question to see what requirements are added on top of the standard Redfish spec. So in this case, we see that this service did fail one of the profile checks. So within computer system, it could not find in chassis, we have links to the computer systems that are contained in that chassis. And in this case, this given chassis instance does not have a reference to its computer systems, and so that's marked as a failure, so D&E does not exist. And lastly, with the use case checkers, these are much more kind of fine-tuned types of testing. The results are not as pretty as the other tools at this point. But the idea with the use case checkers is that you do more functional validation of your service. So can I consistently do a one-time boot against multiple implementations? So can I patch the one-time boot property? Does it behave as I expected after I reset a computer system? Power and thermal checker, so this will crawl the chassis model, make sure that each of the chassis has power and thermal resources and has valid readings available. Power control checker, can I walk through all the computer systems and reboot them as advertised by the service? Account management, so can I go walk through the account service, create new user accounts, change their roles, delete them in the end, make sure that I can log in at the right privilege level of the new account I created, or can I give it a bad password, make sure that the credentials are rejected when I try to log in? So that type of functional testing. Query parameters, there are optional query parameters in Redfish, so things like can I expand a resource and get subordinate resources? Can I do filter operations? So this will walk through the service and try some query parameter checking based on what's advertised by the service. And then lastly, manager Ethernet interface checker. So this is checking to make sure properties within the manager Ethernet interfaces are presented consistently based on recommendations in the spec. Some of the behaviors we've seen in the past have been things like properties coming and going based on the configuration of the interface, which is really not in best practice when you're thinking about command line scripts where people want to set things up consistently, inspect it later, and then maybe hit one switch in the end to enact a group of settings. So our call to action is, based on these tools, we'd like folks to try these out on their own projects to make sure that their interfaces are conformant with what's being recommended by OCP. So getting familiar with the tools, running them, looking at the results, and if you have problems or you have requests for enhancement, maybe there's something that doesn't look quite right, maybe you want to polish something up, maybe there's a gap in the testing, you want to propose a new use case checker, please file an issue for that request. We review everything weekly. I personally do it several times a week. For more information, you can check out the OCP profiles that we have on the Open Compute Project OCP Profiles GitHub link, or go to the DMTF's GitHub page for all the tools that we publish. All right, thank you.